Thin events versus fat events. In event-driven architecture, you're likely going to end up with one of the two. In most situations, I recommend thin events, but here's how you do it without synchronously calling the producer to get extra data. Hey everybody, it's Derek Martin from CodeOpinion.com. If you're new to my channel, I post videos on software architecture and design in .NET, so if you're into those topics, make sure to subscribe. So let's start talking about fat events. So I'm in my loosely coupled monolith that I've been using for all my other videos, and the source for this is available on GitHub. I'll have a link in the description. But I have my order placed event, and I've added two new properties, shipping address and billing address of the address type. Now, the thing with fat events is that they generally don't start out fat. Generally, they end up starting out fairly thin, but you keep adding stuff as consumers get added. So let's say we have a new consumer that cares about something to do with, maybe it's in our CRM context. So we all of a sudden want to put in here the customer ID. And then we have another context that wants more data or needs some other data related to this event or what actually occurred. And then we add it. The problem therein lies if we don't know what consumers or producers we actually have at any given time in the future. So let's say that our CRM context that needed that customer ID, let's say it goes away or whatever consumer it was just doesn't care anymore. Well, there's no way that we can remove this customer ID. We don't know about it. We don't know what is using those particular properties. So ultimately, fat events just get fatter. So then the answer is, okay, well, thin events are good, and it's what I recommend, but how do you know what data to include in thin events? So the way that I've heard and read about this implemented the most often, which I still think is incorrect, is to use delta events. So if you were to think about event sourcing, when you're creating events in event sourcing, you're really just adding the data that represents the state transition. So like the delta of what is now the current state and how it got there. Now the problem with this is how we got to fat events in the first place. So to illustrate this is we have our request come into our context, we hit our database, we make some straight state transition. And then what we do is we create our event and send that to the message broker. Now that event is picked up by some other context in our system. And okay, now it doesn't have all the data it needs from that event. What does it go do? Most often, it makes some synchronous call via HTTP if you are doing microservices or services, or if you're in a loosely coupled monolith like I've been talking about, this is just in process to then fetch more data that that particular context provides via some interface or something. But that's not ideal because now we've just introduced coupling again. The whole point of messaging is to avoid this coupling. So how can we provide all the information that we know everybody's going to need without creating fat events? So the first thing that's wrong in this whole thing is just the thought of where the boundaries are between my two services. So one of the tenets of SOA that I use all the time is that boundaries are explicit. So what exactly are my boundaries here? So I have this order placed event and it has the shipping address. And if I look over to one of the consumers, which was our shipping context here, it needed that shipping information a part of the order placed event. That was kind of the workflow that we had, was an order was placed. And if you can visually think of this, when somebody's entering an order, they fill in their shipping information, they click place order, and then that's what ultimately went to our sales, which published this event. But that idea of that workflow is actually what's wrong. So the first thing that's wrong is this shipping information does not even belong within the sales context. It should actually belong within shipping. So this order placed event, let's get rid of this information because it actually doesn't even belong here, nor is it actually even owned by sales. So in order for shipping to actually be the owner of that data, you actually need to make a request to shipping to give it that shipping information. So in my example here, I have the HP server making a request. Say the client makes a request to put shipping with some identifier, which is going to be that GUID is the order ID. So let's say this middle particular context is shipping. Once the user goes beyond shipping, and let's say then they can click the place order button, at that point, it's using this other context, which is sales, and making a post call to sales, which we already had, with that exact same order ID. Now, this is the key point here, is that this workflow we've actually done with the client making the relevant requests in the order that they need to. But using the order ID is what they've generated. So our shipping now owns the shipping information. Sales owns the order being placed. So when that event occurs that we have being sent out, the order placed with a particular order ID, shipping now already knows about the shipping address. So if I jump back over to the create shipping label, at this particular point, I don't need that information in the event. I can fetch it from my own context, the database that's within my context. So at this point here is where I'd actually be going to hit my database to get the shipping information. So it's about boundaries, about putting the data where data is actually owned and the boundary that it's actually owned is the key piece here. So having those explicit boundaries. And then the second piece of the puzzle is having some identifier that you know is the same between these boundaries. So I know it's the same order ID between sales and shipping, and that sales isn't creating the order ID. It's created ahead of time by the client, and we're using that across multiple requests to each different context. So when you're thinking about fat events or thin events, and hopefully you're thinking about thin events now, maybe stop thinking about delta events and the state transitions, but rather start thinking about the data that you're including in an event from the producer. Is that data really owned by the producer, or should it be owned by some other part of the system, specifically the part of the system where the consumer is that you really need that data? So that's what I would be taking a look at if you're kind of running into the situation, a fat event, or trying to figure out what data you should include in your events. If you have any questions or thoughts, make sure to leave them in the comment section. The last videos have had a lot of great questions and different various comments, which I really appreciate. So thanks. If you enjoyed this video, give it a thumbs up, and please subscribe for more software architecture related videos.